So, have you ever really stopped to think about how Amazon just knows everything you've ever bought? Or how a university can pull up your entire academic record in seconds, flawless, out of thousands of students? These things are powered by a technology you're using literally every single day, most of the time without even knowing it. It is the invisible engine of our digital world, and today we're popping the hood to see what it is. The secret behind all of that? It's an elegant, incredibly powerful technology that is humming away behind almost every app, every website, and every digital service you interact with. We're talking about the database. To really get why databases are so revolutionary, you kind of have to see what things were like before they existed. Just picture a big organization where every single department had its own completely separate digital filing cabinet. That was the reality, and it was chaos. And you can really see the difference right here. With that old file processing approach, you just had a mess. The registrar's office had their own student files, the accounting office had theirs, and so on. This meant the same data was copied over and over again, which led to all sorts of inconsistencies. It was a total nightmare to keep everything in sync. The database approach just wipes all that away by creating a single, shared source of truth. So along comes the solution. And a database wasn't just, a slight improvement. It was a fundamentally new way of thinking, a way to bring actual logic and order to all that digital information. And when you break it down, the official definition is actually pretty simple and, elegant. A database has three main ingredients. First, it represents a real-world mini-world, like a university or a bank. Second, all the data inside it is logically coherent, meaning it all fits together in a way that makes sense. And third, it's always built for a specific purpose, whether that's tracking inventory or managing student grades. But here's a really important point. The database itself, it's just the data. It's just a collection of files. The real magic, the actual brains of the operation, that's a whole other piece of the puzzle. It's a special kind of software. And that's what we call a database management system, or DBMS for short. The easiest way to think about it is like this. The DBMS is the librarian for your data. It's the gatekeeper, the manager that handles every single interaction, making sure everything stays organized, secure, and easy to find. So what does this DBMS actually do? Well, it juggles four main jobs. First, it's in charge of defining the rules, what kind of data goes where and its structure. Then it constructs the database, actually saving that data onto a disk. It also lets you manipulate the data, which is just a fancy word for asking questions or making updates. And finally, it handles sharing, which is crucial for letting lots of people use the data at the same time without tripping over each other. Okay, so we've got the data itself, and we've got the smart software that manages it. How does this whole thing work together as a system? Let's build it out, layer by layer. Everything starts right here at the top, with people. This could be users like you and me using an app, or programmers writing code. We make requests either by clicking a button in an app or by writing a specific question, called a query. That request then zips down to the next layer, the DBMS software. This is the brain, remember? It takes our request, figures out what we're asking for, and then makes a plan to go find exactly the right pieces of data to answer it. And this brings us to the very foundation. The DBMS software dives down and interacts with two things. First, the stored database itself, all that raw information. And second, something called metadata. Metadata is just data about the data. Think of it like the database's own instruction manual. All these parts working together, that's your complete database system. Okay, I know that was all a bit abstract, so let's bring this down to earth and make it super clear with that classic university database example. First up, pretty straightforward, right? You've got a file or a table that is just for students. Each row is a different student with columns for their name, student ID number, class, and their major. Simple. Then you've got another separate table just for courses. This thing lists out every single course the university offers, along with its name, its course number, how many credits it's worth, and which department offers it. Now, pay attention, because this one is the special connector piece. The grade report file doesn't bother storing the full student name or the full course name. Nope. Instead, it just uses their ID numbers to create a link between them, and then it stores the grade. This is the glue that holds all the different pieces of information together. And this is where the magic really happens. See, the real power isn't just having these separate lists of data. It's the ability of the DBMS to manipulate it, to reach into these different tables, grab related pieces of information, and combine them to create something totally new and useful. So for example, when you ask for a student's transcript, the DBMS works its magic. It zips over to the student table to get the student's name. Then it finds all their courses and grades in the grade_report table. Then it hops over to the course table to look up the full names of those courses. And bam, it builds a complete transcript. Now think about this. That transcript didn't exist as a single file anywhere. It was created completely on the fly. This amazing ability to manipulate data is just one of several absolute game-changing advantages of the database approach. So to wrap up, let's take a look at what we're going to call the database superpowers. We're going to look at 4 big ones: its self-describing nature, something called program data independence, its support for multiple views, and multi-user transaction processing. Okay, superpower number 1, a database knows itself. It doesn't just store your data, it stores its own blueprint. The structure, the rules, everything, right alongside the data in what's called a catalog. This data about data, this metadata, means the whole system is self-contained and intelligent. Now, this next one, program data independence, is arguably the most important superpower of all. See, in the old days, programs and the data they used were basically handcuffed together. If you wanted to change the data structure, like add a new column for an email address, you had to go and rewrite the entire program. The database way completely decouples them. The program just asks the DBMS for what it needs, so you can change how the data is stored underneath and your applications don't break. This was, and still is, a total game changer for developers. The last 2 superpowers really build on this. We've already seen multiple views in action with that student transcript. Different users can get customized views of the exact same data. And multi-user processing is what lets hundreds of people book airline tickets at the exact same moment without the system double booking a seat. The DBMS just handles it all seamlessly in the background. So there you have it. From what were basically clumsy digital filing cabinets to this incredibly powerful, self-aware system, databases have truly become the unseen engine of our modern lives. They give us structure, flexibility, and access to information on a scale we could have never imagined. But as they become the keepers of more and more of our world, from our health records to our shopping habits, it leaves us with one final big question to think about. Who should we trust to hold the keys?